Welcome to the nutshell class version of our Physics 30 topic 1.02, where we're going to be focusing on regression, particularly linear regression. So this is a review of topics that were covered in Math 30-2. So what we're trying to do with these is we are trying to find data and find the straight line that best represents the data. So let's imagine we have some points that are kind of around a straight line, not exactly, but that is the way the real world works because of some uncertainties in measurement and quantum mechanics, uncertainties in the universe itself. We often don't have data that fits exactly on the line, just close to the line. So we can figure out what line is the best fit. So if we see the squared residuals, we have a line right now where our slope and intercept are both 0. With these residuals, that's how far these points are from the line. So let's say we put it around here. That seems to be a decent fit. We still have some of these lines or residuals. If we look at the squared residuals, we see that each of those becomes a square. And the goal of regression, which we are not going to be doing by hand, is to figure out what values of our slope and intercept have the lowest total areas of these squares. So we've done this a little bit by hand now just to get a feel for it. We'll actually do the best fit line. So that's actually not far off of what we had. We've got the 0.38 for the slope and the 4.58 for the y-intercept. This is fairly close. So let's turn our line off and we'll take a look at our squared residuals. We see here that that's the sum. So it's minimized. So that is the best fit we can have for this line. And the reason we're going to be doing this is because a lot of our data that we have, we are going to be graphing in a linear fashion. So we'll be tweaking and altering the data somewhat to make it a straight line. So, or at least to make it so that the theory predicts it'll be a straight line. Not all of our experiments are going to be consistent with theory, as we will see by the end of this week. And that doesn't mean the experiment is bad. Sometimes it means the theory is inaccurate or at least incomplete. But this is our best fit line. So we see this line and the computer has gone through and adjusted it. So we can try to find the best fit ourselves, but really there are mathematical ways to make sure that we do have the best fit, the absolute minimum total area for all of these data points. And of course, that depends on which data points we have. As we move one data point further from the line, it starts to skew and drag everything away. But we can move our data points and find them closer to the line. So depending on how precisely measured they are, what kind of spread we have, we can get them really close. We can get situations where a lot of them are quite a bit out. So the simulation is a good way to visualize what's actually happening. So we see with that one point, as I move that point around, the best fit line will move to try to adapt and minimize how much area we are adding for that square. So again, each of these squares, we just figure out how far this point is from the line in the y direction and just in the y, and then figure out, well, what's the square of that area. The reason we deal with squares and not just the distances is because we have that up and down. If it was just the distances, we might end up with some negative values. We want to make sure the answer is unique, and if they're negative, they're not unique. Another reason that we deal more with the squares, digs deep into statistics, but you can statistically show that looking at the squares instead of just the absolute values of the residuals gets you a more accurate picture of what's really going on. But the statistics required to prove that are a little bit beyond the high school level. So at this point, I'll just have to ask you to take that on faith. But for these regressions, we can use our calculators. We will be using spreadsheets much more often, typically Google Sheets, because that is the one that the school provides for everyone. But if you prefer to work with Excel, Numbers, OpenOffice, StarOffice, LibreOffice, take your pick. I am not picky as long as everything is still submitted through the Google Classroom for your labs.